Good morning. I'm going to try and show how to use the base 10 blocks to model multiplication. The idea here is area. So if we're thinking about modeling multiplication, one of the meanings of multiplication is area. So for example, I'm going to model 16 times 34, and we're going to use an area model to do that. So I'm going to bend this down so that hopefully you can see the paper here. Okay, so I'm going to show 16 on this side. So 10, 11, 12, 13, 14, 15, 16. And then I'm going to show 34 on this side. 1, 2, 3. So there's 30, 10, 20, 30. 1, 2, 3, 4. Let's see. I think you can see all of that. Of course not. All right, I'll try and adjust as I go. Sorry, I don't have the best setup right now for showing this. All right, so I've got 34 by 16. Now with the area model, the answer to our multiplication is going to be what we fill in inside. So I'm going to try and fill in our area model here. Okay, now I've got to grab some more base 10 blocks, sorry. I'm going to try and do this with different colors, but I don't think I have enough of the same color. So when I'm filling in the area model, right, notice here I've got 10 times 10. 10 times 10 is 100, so filling that in, I'd use a flat. Again, here I have 10 times 10, so filling that in would be another 100. Here I have 10 times 10, filling that in would be a third 100. Okay, now if I keep moving in and filling in this model, here I have 10 times 1. Well, 10 times 1 is 10, so I can fill that in with a long. Notice that also kind of matches how this fits together kind of geometrically. So 10 times 1, 10 times 1, 10 times 1, 10 times 1. Coming down here, oops, make sure you can see that. Coming down here, I have 1 times 10 again, so that's going to be 10, and another 10, and then another 10, and another 10, another 10, and another 10. Phew, we ran out of 10. Oh, maybe not. I got more. And then again, 10 times 1, 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 10 times 1. And I still have to do that again for this row because I've got 10 times 1. So I'm still filling in here. Phew. Okay, and then over here, I'm looking at, right? I moved. Oh. I'm looking at 1 times 1. Well, 1 times 1 is 1, so I'm going to fill each of these in with little units. So 1 times 1, 1 times 1, 1 times 1, 1 times 1. It's a little tedious, but that's okay. Should have picked smaller numbers. Ooh. Oh, ran out of units. All right, I'm going to steal some more units. Let's see. Let's do all kinds of multicolors here. Okay, so now we've filled in this area model. So what we have here is the solution, again, to 16 times 34. To more easily kind of see our solution, I'm going to move my edge pieces off. Those were just kind of explaining what I was multiplying and helping me fill in. And notice if I squish all my pieces together, I've made a nice rectangle here. The area of that rectangle is going to be the solution to my multiplication problem. I'm not doing a good job of squishing today. Hope your patience is high this morning. There we go. Okay, so then our solution is going to be this area right here. And we can kind of count up that area. And often we sort of do it in parts. So I might say, okay, these hundreds, 100, 200, 300, give me 300. And then this group of ones, I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180 is 180. And then this group of 10s, 10, 20, 30, 40. That wasn't so bad. Oops. And then our last little set of units there, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So then our overall solution to this problem will be 300 plus 180 plus 40 plus 24. 0 plus 0, you can't see that. 0 plus 0 plus 0 is 4. 8 plus 4 is 12, plus 2 more is 14. 3, 4, 5. So 34 times 16 should be 544. So that's kind of doing it with physical manipulative. So looking at kind of what's going on physically. Now if I make a little bit of room, need a bigger desk, okay, we can sort of simulate the same thing with just a drawing or a sketch. So if I want to do 16 times 34, I'm going to model that by, again, showing 16. So 1, 2, 3, 4, 5, 6. So 1 long and 6 units by 34, 10, 20, 30, 1, 2, 3, 4. And then I'm going to fill in. Okay, so as I fill in, 10 times 10 gives me a flat, or 100. 10 times 10 gives me another 100. 10 times 10, another 100. So altogether, again, I've got 300 from those, multiplying the 10s times the 10s. Now here I've got a unit times a 10, so that's 10. A unit times a 10, 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 unit times a 10. Phew. So altogether that's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180. I'm glad we got the same thing that we did the last time. Again, over here, I've got a 10 times a unit, so I'm going to fill that in with 10s. That gives me 40. And then last in the little corner, I've got units times units, so I fill those in with units. Okay, altogether that gives me 1, 2, 3, 4, 8, 12, 16, 20, 24 units. Okay, so again, to get my final answer, I sum all of those up. So 300, 180, 40, and 24. Adding those all together. So 8, 9, 10, 11, 12, 13, 14, 3, 4, 5 gives me 544. Last step is we can connect this to something called partial products. So partial products is a way of multiplying something like 16 times 34, okay? But doing it in a way that's really similar to this. So what I'm going to do is I'm going to think of 16 as 10 plus 6, that's certainly 16. And I'm going to think of 34 as 30 plus 4. And then I'm going to do the multiplication sort of separately. So I can first multiply 10 times 30. That gives me 300. Then I can multiply, say, 10 times 4. That gives me 40. Then I can multiply 6 times 30. That gives me 180. And last, I can multiply 6 times 4. That gives me 24. Notice those numbers, 300, 40, 180, 24 are exactly what's appearing with our picture. Summing all these together gives me, again, my final answer of 544. So that's how we can use the base 10 blocks, either very concretely, meaning I'm actually building a model with physical base 10 blocks, or kind of a more abstract model where I'm using the base 10 blocks on paper to model, or I can use partial products to kind of short circuit this process. Either way, I get the same answer.